Hello and welcome to my Docker and Docker Compose Just Enough course. This course is a summary of over 30 hours of watching tutorials from various platforms and reading the official documentation and reading articles. And I'm going to summarize all of this information under just 3 hours, besides including 6 Docker projects. I will also going to discuss everything you need to know: what are containers, what is Docker, to container networking, and how to use Docker CLI, and writing Dockerfile, and using Docker Compose to launch multi-container structure, and even pushing a Docker image to DockerHub. So all of this including the 6 practical projects. So let's get starting. And before diving deep into Docker, as we would like to do in these videos, is trying to understand the concepts first. And we need to answer the biggest question, which is why Docker? Why we need to use Docker containers? Or how was the world before Docker or the whole container thing? So before this whole concept, at first we had normal servers that you have like a normal server, and then you have inside it like your application, and then you have your database, and maybe it is connected to another application in the backend to do like maybe this one is doing like payment, and this one is doing like users to get like users from it, and inside this app you have like another database, and these were like actual servers. And the problem with using bare metal server is that as a developer, when you are developing your application and then you try to deploy it on the server, it might not work. It like the whole problem of it doesn't work on it works on my machine, but it doesn't work on yours. So you might develop it on your operating system, but somehow inside the server it doesn't work because it's on another operating system. This was one of the biggest issues. Second issue is that this application have like huge access, like they have complete access inside the server, and you need to maybe like make correct user groups and users and give them permissions and credentials, and sometimes it could get out of hand and you might not set up them correctly. So there were a lot of problems, like there were problems with consistency inside the code and problem with security as well. So they said, okay, let's go with another thing or another solution, is that instead of having like these apps inside our server, and also there wouldn't be usually one app, there could be like multiple apps inside your server, and these are even competing with each other. So also the third problem is competition among resources. So they said, okay, let's try to get a solution to solve this, and the solution they came with is with virtual machines. So this was the solution that they thought of. And basically inside the virtual machine, they would have 3 layers. The first layer, they would say, okay, we would have an operating system. Like we would have the operating system layer, and then we have different libraries that supports our application, and then we deploy our app. So maybe our app requires PHP or Java. So in this case, we add it inside these libraries, and we need like Ubuntu for running the server. And in this case, we create a virtual machine, and with virtual machine, we solve the problem with security because we could control what is going in and outside of this virtual machine. We could also control resources. You remember, if you used VirtualBox, you could determine how much memory you would like to use, how much CPU, and so on. And also like the idea of deployability, because eventually when you develop your code, you could deploy it on the same operating system, and you could develop your code inside a virtual machine and test it before deploying. And this was a fine solution, but the problem with this one, like you can imagine, it is not a single app, but rather there would be another one, and the other one would also have the same layers. It would have the operating system, it would have libraries, and it would have an app as well, or different apps even. Like it could be have like database, for example, here. And the problem with this, you see, like it was fine at first, but the problem with this is that you have the same layer of operating system. It's always consistent. Like these libraries could be changed because this is like a different apps, but the operating system is normally consistent. People usually use Ubuntu, for example, or Linux, and this one is huge. So it's huge to start the virtual machine. It's huge to, if it fails, you need to rebuild it again maybe, or restart it. So it takes a lot of time. It takes a lot of time to deploy. It takes a lot of time to restart. If you need more virtual machines, for example, because you have a lot of traffic, it would take much time to like ramp up the traffic and be able to serve them. So they said, okay, we actually don't need to always serve an operating system with our application. Maybe we could unify this whole, or share the idea of sharing operating system. So instead of having for each application an operating system, let's share operating system among them. And this is a containers. Like the idea of containers is that you only restrict access, like you take like a virtual machine, but you would share the operating system. You wouldn't have like a specific operating system for each of your apps, but you would deliver the libraries and you deliver the app like inside your container. And this is the whole idea of containers, difference between virtual machines. So this was a whole concept why eventually we needed to have containers. So it would be taking the benefits of virtual machines, so consistency when we are developing code. It is much easier to run instead of starting a whole virtual machine on your laptop. For example, if you try it, it might take like 1 minute to start. So it takes a lot of time. This is a lot of time. And it's also like lightweight and you don't need huge space. And also it would be much, much faster because you run on an operating system, but rather not like virtual machine. And there is like another operating system down there serving these virtual machines. So it would take like much less resources. So it's faster, it's more consistent, and it delivers value. So this is why we needed containers, like coming from the whole idea of bare metal, like from bare metal to virtual machines and eventually into containers. Okay, so now we know what is the containers in like the concept of it, but how it does it, like how the whole container is working. So let's yes. Okay, so let's go to another page. And a container, like we said, is similar to virtual machine, but let's not think of it as virtual machine, but rather it's just an app and supporting libraries, these two. And then there is isolation from the outside world. It's basically like just a process. It's a normal program. It is nothing more than this. Like if you, like at first I didn't understand the whole idea of containers. I thought, okay, it's a virtual machine. It's constrained from the outside, but no. It's not like that. It actually just a normal process, like similar to what you have here on your laptop. Like if you check like these processes, it's exactly like that. But the only extra stuff, they have their supporting libraries that they need. Maybe, for example, they need some image processing library, or they need some extra library to save or get like curl to get like data from outside. So they just have these libraries to help them to build, like basically similar to NodeJs, not Node.js, Node modules. Like similar to having Node modules inside your app, and instead of like installing them and so on. And plus all this, the idea of isolation. Like here I have PHP Visual Studio Code, and if I try to file, like I go to this one and then I try to open folder, I see like everything. No, with containers, you don't have this access. You only limit it to your container. You cannot access folders from outside. So this is the concept also of container. So how containers does this part, or what are these technologies, like is this magic or something, or is this very complicated? And actually it is no, like it's actually not even related to Docker. It's basic Linux like libraries and kernel stuff. It's very things that supported by every operating system. So they needed 3 technologies to be able to get to the idea of containers. The first one is namespaces, and second one is called Shroot, and the third one is C groups. So what each one of these? So namespaces is to constrain containers from seeing the outside processes. So if you, I don't know, like go to your terminal and then you write PS, you would be able to see the other processes running. And there are extra commands to be able to see the whole processes inside your system. And the idea of using namespaces is just to constrain each container from accessing all the processes. So it's only seeing its own process. So it would be the app. Like we said, the app is a process. So in this case, if you have Python or like you have Node.js application running, so it only sees its own process and maybe extra process that it needs. But all of them are only constrained to this app. The app cannot see like other processes, like it cannot see your documents file or your images or like whatever would it be. But away from these files, so the first part is just like namespaces is constrained from seeing the running processes. The second one, which is shroot prevents like seeing other files. Okay, how it does it? So if I go to my terminal and then I write pwd, which is getting like the current directory, you see, you know, like the slash is your origin or like the top level directory, but you can still see the other directories. Shroot, what it does is that it says, okay, actually your root is not this original root, but rather maybe a subfolder. So in this case, you could have like maybe like this Docker course, and then when I write cd dash, it would actually go to only Docker course. It would start your root from this folder or this directory. So shroot is like change root. It's basically changing the root for your application. So what the app could be, like what the app is able to see, it can only see it like the ones that you defined in shroot. In this case, you would define like a certain folder. Hey, this is all the files you can see. You cannot see anything outside of it. So this is the second technology. Third technology is cgroups, and cgroups is to limit resources. So you remember when we here at the virtual machine problem, like you could have like two apps running on the same bare metal machine, but this app maybe it would start to grow and it would take over your whole server and it could kill the other apps, and this is not what you would like to have. So you would like to limit resources. You would say, okay, this app can only take 1 gigabyte of RAM, maybe like 2 gigabytes of hard disk, maybe 1 core CPU, and so on. So only you limit the resources for the app to these stuff. And how we limit them? We limit them using cgroups. In this case, we have the same benefits that we have in the virtual machine of limiting resources, but this one is like lightweight without the whole operating system stuff from the virtual machine. So this technology actually exists in every kernel. Like it's not related to Docker even. It's just like normal container technology. This is how containers are created, how they are managed, and how they are handled. Like these are the only three basics. This one, like we said, to limit processes, and this one to change the root itself, the root file, to be able not to see like all files, and the third one is to limit resources. And this is how we have the isolation. So now we have the isolation technology for our containers. And this is basic stuff. Like even people when developed or tried to create containers, they created even before Docker. And there were multiple container technologies other than Docker. But just like Docker became famous because it's very like reliable, it's very consistent, and it's like has a huge support. So it was great to use this technology. So it's very supported. So yeah, this is also how containers technology works. So now after we understand it, containers, now is the time to understand what is Docker. So Docker is just an application that manages containers. That's it. It doesn't do more than this. So basically, Docker is just an application that manages other containers, to create them, to stop them, to run them. It's basically your activity monitor or your task manager on Windows. So just like an application to manage these processes, to say, okay, I will kill this one, I will start this one, and so on. It's not nothing more than this. And it simplifies a lot what is Docker is, because Docker for me at first it was magic, but now I totally understand. Like it's just like processes to run processes and so on. So Docker consists of three parts. The first and important part is the Docker daemon, and Docker daemon is just starts and stops and pauses and kills and creates containers or your processes. So it can create and like create containers and so on, stop them and do all the operation tasks. And it needs to create them from somewhere, and it creates them from images. And you can think of images like the CD or DVD or the floppy disk. If you lived during this age, just comment like if you have ever saw like floppy disk before. And yeah, so basically it's just like an image. And it's just like your CD, basically. It says, okay, this is your, like this is the whole application with all the libraries and everything that needs to run my application. So maybe you need to run like an Ubuntu, just like take the libraries of Ubuntu and nothing else. Maybe you would like to run Bash, maybe you would like to run Nginx, maybe you would like to run NodeJS, PHP, Python, Java, until like a complete application like WordPress. So you could run a full stack thing using Docker images. So the image is just something that contains the applications that needs to run and the main applications that would run inside it. And always these images would have a single application that needs to run. Maybe they can support multiple processes, but this is like a different story. So like we said, we have containers that runs, and then we have images that are the source to run from. And then after we have like the Docker daemon, there is something called registry. So registry is a place where all these images are stored in. So you can think of it like GitHub, and there are repositories, and then you clone the repository. So it's similar to this. There are images there, and then you can pull. It's like similar to clone. Yes, like similar to clone. So you have pull, you have push as well. You can push to this registry, similar to git push, for example. You could also get like Docker commit, similar to git commit, and then create like different commits and push them, but this would appear later. But registry is just a place to store these images, to store these CDs. And the famous one is DockerHub. This is where like every public image is stored there. So you would have inside it like thousands of images stored. So if we go to DockerHub, so you would have like multiple images when you go inside it, and you are able to git pull or git push from them, or get them, or do whatever you would like to do. So maybe you would like, I don't know, like Nginx image, and then you would find the official one. So this is the official one that is from like Docker itself, and there are also like verified stuff as well. Like Bitnami is also one of the famous ones. Maybe you would like to get WordPress, maybe you would like to get like Ghost, like also this one for plugging stuff. So there are multiple images that you would like to get. So all of them are on the registry, and there is also support for private registries as well. So there is one called Nexus, and this you could have like on-premise registries. There are also like multiple technologies, but just Nexus because this is the one that I dealt before with. And there is also ones on AWS as well, and GCP, and also Azure, like your usual cloud platforms. Each one of them would have their own Docker registry. So you have like this support, and also DockerHub supports that you could have like private ones as well. So we have, like we said, we have the Docker daemon, creates containers, images, and images we get always from the registry. Okay, how we communicate with the Docker daemon to tell it, hey, please create this container, or stop this container and kill it and run it and so on. As you see, it's from the client. So the client is just an application. It could be the normal CLI. It could be an SDK for from a language that you would like to use, like maybe Python or Go as an API to it. So basically it's just an interface to communicate with the Docker daemon, because we don't like communicate directly with the Docker daemon, but rather we have like a client, a CLI, or an SDK that we communicate with. So this one is a CLI tool. This is the one that most stuff that you see. You could also use one from programming languages as well, like Go and Python. Like they're also these stuff. But the ones that we are going to do in this video is the CLI. And with the CLI, you could build, you could pull, you could push, you could like start, you could stop, and we are going to discuss all of these things. So this is what is Docker, like how Docker behaves, what are the different parts of it, and the architecture of Docker itself. And now last concept part. I know like you would like to see the CLI and the command line, but all of this is crucial to be able to understand the concept. Like we said, in these videos, we would like to understand the concepts and then use that tool. The tool could change tomorrow, it could change after. Like there are always tools coming up. Docker wouldn't live forever. There would be another tool. So understanding the concepts would help you to eventually, like when there is a new tool, oh yeah, I now know what are the concepts. I just like map the commands that was before to this one, and then I start using it. So Docker is famous today, but who knows? It could die tomorrow. No one knows. Okay, so now this is the last part, which is the life cycle of a container. So we know like these containers are created from Docker daemon. Now is the time to understand what is the life cycle. And away from all of this short, just think what normally when you have an application, what you usually would do. When you would like to install maybe Office, or I don't know, like Spotify, or whatever application you would like to install, or a game from Steam, for example. So Steam is a good example. You have like a game and you would like to install. So you have your game, which is the Docker registry, and then you would like to first download it. So downloading the game, and this would be the Docker pull. So basically you are getting the image from up, like from Steam. And then After it is downloaded, you would like to install it. And installation would be the create process. So you would create your game basically, like to be able to install it. And after you install it, you need to start it. So to run it. So basically you click like start the game, and then the game starts, and then you play. Maybe during the middle of the play, you would like, of course, like you haven't done this before, which is pausing the game. By the way, pausing is different, like the actual pause of the process. But let's think of pausing the game. You pause the game, and maybe afterwards you would continue playing the game, and after you finish, you would like close it or kill it. So it's the same thing. It's the normal process. It's a normal process. Like Docker container just really is just a process. So it's the same thing. You have like Docker pull you would get from the registry, then you would create, which would be basically like installing, and then you would start. And after you start, you would run the image. The image itself will start running and playing, and then you can pause it. By the way, like pause this one is different in the games, because pause here is just like freezing the process itself. It's something related to Linux. I never used it before, but just for you to know, like as a knowledge. But usually after you run, you would stop it. So you would stop the image. So either you would kill it, or you would like maybe remove it, and so on. So either like you kill it, kills automatically because it's out of memory. You see, like sometimes your game stops or crashes, or you actually like kill it. And then after you kill it, it's now in the stopped phase. And after you stopped, you uninstall it, which is deleting in our case. So this is just like a normal Docker. It's similar to how you install software, but just like isolated, and they have like well-defined designs. So it would be similar to what we see here. So we would pull it, an image, we would create it, we would run it, we would stop it, and then we would delete it. We wouldn't do pause because pause is not important. It's just like pause and unpause. I would add the command if you would like to play with it. So this is the concept of the Docker lifecycle. And now let's jump to the command line. And the first part is trying to install a certain image, and or basically like in terms now we would use the terms of Docker is to Docker pull. So when we would like to get a certain image, we would go to DockerHub, and we would say, okay, I would like to get Ubuntu. For example, this is the image I would like to install. Then I would go to Ubuntu. Let's just close this one. And then you would have multiple versions that you are able to use for your system. Either you could specify a certain version, or you could like say no version, and then it would download always the latest version for this image. So the command would be docker pull, and that's the name of the image. By the way, I wouldn't show like the installation of Docker. There are a ton of videos on how to install it. So like I said, this video is more of a summary rather than like how to install and step by step. Okay, so we have docker pull, and then we could say Ubuntu, and then we would download the latest version. If you would like to download a certain version, you would add like the call. So you could say docker pull, and then Ubuntu, and then you would say I would like maybe 18, for example, or like Bionic. Another image we could like try to download as well is Nginx. So it would be the same stuff. You go to the image, of course, like this is the count of number of imports. I maybe like make this one just better. Yes, okay. And then you would see like multiple images that you are able to download. And Alpine is just like a lightweight. Like most of these images are based on Ubuntu. Like they have something called layers, and we would see like the idea of layers, but they have like multiple layers. They are downloaded, and each one is based on the other. So Nginx, like the default one, is based on Ubuntu, but maybe you would like to be based on Alpine. Alpine is like lightweight of Linux. So it has like only the libraries that you need. Okay, so we could say docker pull Nginx. I wouldn't do Alpine now. I was just like docker pull Nginx, and you would be able to see the idea of layers. So you see like there are multiple stuff that are being downloaded because I already downloaded them, so they already exist. So you would see these are the different layers that like make up my image. So we download it. Now we need to create it. This is the first step, is to create the image, or basically like create a container of it. So we say docker create, and then the name of the image that we would like to create from, like create a container from. And if we do it like this, it would show us like the hash, and then this is the hash for the container. And if I try to go and see it, of course, like it wouldn't run, because the container, like we said, containers are isolated from the outside world. So we need to open it to the outside world. So we will get to this step later. But before this part, let's see if our container is running. And to be able to see containers running, it's similar to when you have like PS here and see the processes. It's also in Docker, you would run Docker PS as well to see the different processes running or containers. So different containers running. So you could write Docker PS and it would show us like, okay, there is nothing actually running because we just only created it. We haven't run it so far. So after we create a container, we need to start it. So what we are going to do is to take this part and then start it. So we say Docker start and then our hash, like the hash for the container. And then when we do it, and then we try to Docker PS again, now we see our image is running. Like we see like the Nginx and it says, okay, the container is running. And it gives us like a random name. It's called like compassionate gates. Okay. Yeah, it usually like gives us random names. So we would like to give it a better name. Like we wouldn't like copy this hashes and so on. So we could actually name our containers. And to name them, we could say Docker create. First, we need to create a new Nginx. So we say this one, but we could give like dash name, and then we say the name of it, maybe our, I don't know, like front-end server. This is our name. And then I could use Docker start and then front-end server. And now it will start our front-end server. And if I see Docker PS, I would be able to see the running processes now. And now I have like 2 Nginx processes running. By the way, again, they are isolated. I cannot access from my machine. So we would see like the idea of accessing them. So we need to, before like going to the accessing point, like we have created, we have now running, we could actually stop it. So we could say Docker and we take the image and we say Docker stop this. And if I run Docker PS, I would only see my single Nginx that is running. And to be able to see the ones that are not running or have stopped, they have destroyed or they have problems, they have exited, errors, whatever, you would write Docker PS-A to see everything. And when you see here, you see like it's exited because we have stopped it at the moment. But this now is stopped. We would like to remove it. And to remove it, we just say Docker RM. It's like, okay, I would just like remove this whole process. Like we have created it, like actually like installing and so on. No, I would like to remove it and only have my image. So I would say Docker RM and then I would say front-end server. Yeah, I have that this space RM. So basically like this. And now if I run Docker PS-A, it would only show me like the one that is running. Okay, one important thing is that 2 Docker containers cannot have the same name. So if I try to create a container with this name, so if I try to Docker create dash name, and then I add the same name for the running one, and then I say Nginx, it would show me an error because you cannot have 2 containers running at the same time with the same name. Why is that? Because it is used for DNS resolution to resolve networking between containers, and we will come to this point later as well in this video. So we'll also discuss the part of networking. So it's important, like 2 containers cannot have like 2 names. You can think of it, 2 containers cannot have the same IP address. Like 2 computers cannot have the same IP address on the same network. So this is why we need to have like names should be always it cannot be repeated. Okay, let's clear all this part. So now we have our process to create, run, stop, and delete. Or maybe also like pause. We could say Docker pause, and then the name of the process that we have at the moment running. And if we run PS, we would see it at the moment like it has paused. And you can also Docker unpause to make it run again. Unpause. Okay, and also I could Docker stop it, and then I could Docker RM to remove it. Now we have everything at the moment for like start and create and all of this, but we don't do that. We don't like create, run, and pull, like we don't like do the pull, create, running. All of this actually could be done in a single command. So we could docker run, and this is a command. We say docker run and whatever you would like to run. Maybe you would like to run Ubuntu, for example, like we would like to run Ubuntu. So if you do it, it would get it, like pull it and create one and start. It does the 3 parts in a single command. So of course, like it would run it, and if you docker ps-a, you would see it already exited, and I will discuss why it exited now. Or upcoming. Okay. Another thing, maybe let's try to run docker run something that I don't have an image for it. So docker run WordPress. It would say, okay, I cannot find WordPress, so it start pulling the image now because I don't have the other stuff. So it start pulling it. If you see, it has like very fancy like progress stuff, and after it downloads, pulling, and now it creates my image. It creates my container. Sorry, but you see, I'm not inside my shell, and the reason for this is that when you run a certain process, it's actually as if you are running a process inside your shell. So if you run, maybe if you try to run Node.js Express application, or maybe your Java server using the development server running on host 3000, or running create React app, you go to another shell to start your application. So it's exactly like that. So you're jumping from your bash or current shell into the process for that application. But we don't want that. We are now stuck. If I click Ctrl+C, I actually now kill my process. And if I run docker ps, I will see it is not, docker ps, I will see nothing is running, because actually you have stopped it, like similar when you click Ctrl+C, and you see like here it says shut down. So to be able to run it, you have to run it in something called detached mode. So you would actually do the command again, but instead of just run, you add -d. And this would say in detached mode. So basically it creates it like in another shell and keep it. And if I do docker ps now, I would see now it is running. So it's just like in detached mode. So this is a part for the idea of detached mode. Now let's go back to the idea of like be able to access Nginx. Like you remember when we try to run our Nginx, we try to run here like docker run Nginx, and we would say in detached mode as well, and we wouldn't add like the name at the moment, we don't care about it, and we just like run it like this and make sure that it's running. We say like our Nginx, and if I try to go to localhost 880 localhost, and of course the default is 80, so it would actually remove it. So it says like nothing is running, and the idea is that, like we said, containers are closed inside themselves, so we would like to open them to the world, like introduce them to the whole world, and instead of like being closed, shut down, we would like to give them capitalism. Anyway, so the idea is that inside the containers, this is now where we discuss the whole networking concept for containers. So a container, like we said, it's isolated from the outside. And we have like another container, we could have another container, and we could have like a fourth container, we could like have hundreds of containers. And these containers are isolated from the outside. You cannot access them, like you cannot access them from outside into there. And like two containers cannot in this case communicate with each other. But of course, like communication is important. We would like to get like data from outside inside our server, like the Nginx server or like WordPress server. And we would like WordPress maybe communicate with the database, or Node.js communicate with MongoDB, and so on and so on. So the idea is that we open them to the world by publishing a port. So we'd say, okay, I would publish port from the outside. We would discuss what is the outside is, but we will publish maybe like port 3000, and we would map it to port 80 inside my container. So in the case of Nginx, we would say, okay, from the outside, which say what is the outside is, and there is a request coming with port 3000, please take any request coming inside this stuff and coming into port 3000, please map it into port 80 inside Nginx. So it would run inside this Nginx as if it is on port 80. Maybe something also in port 4000, please map it inside this one. Maybe it's on 3306, which is the IP address for MySQL database. So please map it inside this one. Maybe there is one here, access like 3000, and there is like 8000 from here. Maybe there is another Nginx server. So we could say, okay, port 7000, please map it into port 80. And this is a good thing. We would like the inside to be similar, because this would be the Nginx image. This would be also the Nginx image, and they have the exact same image. So inside it would be the same, only the outside I could change. But in this case, it would be the exact same stuff. And the question now would be, what is the outside, like this stuff? And this stuff is actually a virtual network. So Docker creates a virtual network to handle the communication between these containers. So like we said, we have, for example, like we are mapping port 3000 to port 80, 7000 to 80, but what is 3000 of what? Because it needs to have an IP. And in this case, the IP would be like the IP for this network. Basically, by the way, I'm oversimplifying this stuff. It's way more complicated than this, but the idea is just like this IP, or the resolution of this IP would be mapped, like an IP for the network into port 3000 would map like this port 3000 specifically to this container, which have a certain IP and port 80 inside it. And each of these containers has an IP address. Like when you started, each one of them has an IP address for them. And there are two important networks inside Docker, and they are the default ones. But of course, like you create as much network as you would like to have. And the first one is the host, and the second one is called the bridge. Okay, what is the difference between each one of them? Let's just create a new page just to have like more clean stuff. So let's have our stuff again, because this part is very critical to understand. So you would have here like two basic containers, this container and this container, and this one has an IP address, and let's say, I don't know, like 127.0.0.1, and then it has port 80 inside it, and this 1.7.0.0.2, and this has also port 80 inside it. And from the outside, this is the outside world, this is the network part. Maybe it has 1.7.1.0.0 for some reason. And in this case, when a request is coming from the outside and it goes to port 3000, it would map it. Okay, I would map this port from 3000 into this port. If I get something from port 4000, I would map it from the outside into this IP address. So it's just like taking like one IP address port and mapping to another IP address and port. And when you create containers at first, you are connecting to something called the bridge container, bridge network. This is like the default network. Each container that we create, when they don't specify a certain network, they are specified to this bridge. And this means that when you write localhost, when you would like to define like what is a local host for me, like for a container, because it's always used for this container, with bridge, localhost would be always the IP for this one. Like it's always attached to this one. Like it's a container IP address. So it's basically like resolving to itself. Like when you say localhost 80, it means that localhost 80 for me. But you cannot say localhost 4000 and then expect it to go to the network. Like you cannot say, okay, I would like to go localhost 4000 and expect it to go to this 4000. No, it doesn't work like that. But rather you have to delegate it to something to say, okay, resolve for me, like get the IP address for this network, like this container. This is what we actually need, because all of them are not the same network. And the resolution of this name, and this is what is Docker providing us, is the Docker name. And this is why we can't have two containers with the exact name. A Docker container always have like its own name. You cannot have two containers with the same name. So basically we would say instead of localhost 4000, you wouldn't write it as that, but rather you would say, I don't know, like this is the DP, you would say DP 4000, and then you handle it to the network, and the network, okay, would try to resolve it. Oh, like DP is the name for this container, okay, I would now map it to this one. But if you write like localhost, it would actually go again, because localhost is the same IP address. So this is under the bridge network. There is another one called the host network, and this one is actually the Docker daemon itself. So this is of course, like, I don't know how to write it correctly, but yeah, anyway, so this is the Docker daemon itself, and basically instead of having the local host bound to the IP address of itself, no, the IP address wouldn't be this one, but rather would be the host address. So this is the idea. And when you bound to the host address, and if you also bound the database to the host address, now you could actually use the local host. Why? Because using the local host now, both of them would resolve to the Docker daemon IP address instead of their own address. And now you could, yeah, you could write like 4000 and access this one. But of course, no one does that, because this is one like has like high leverage basically. And we usually either have the bridge or we create our own custom network. Like this is also what usually we do, like create the custom network, and now we could map and DNS and like resolve all of this stuff. Of course, like this part is complicated, and like I said, I am oversimplifying it, because the whole networking thing could be like its own specialty basically for Docker. Okay, so well, let's rewind back. What we would like to do, we would like to open it to the outside world. So there is a simple command to do all of this stuff, which is called docker-p. And with -p, you are saying, okay, I would like to publish this port, like from the outside, from my local host, from the host machine, into the container itself, like this part. Like we would like to map the outside network machine, which is local host, this is outside, and map it to this port, because I would like to be able to use it, to resolve it basically. And Docker itself does the whole like mapping, like from Docker from outside, like the local host, into its own network. It does like all of this stuff. And before we do the -p, if you would like to see all the networks, you could write Docker network ls, I guess. Yes, and you would be able to see. So you have like bridge, and you have also the host, not this one, but this one. You have bridge and you have the host. And when you create a network, you create it on the bridge. So if we write Docker ps, and we take this Docker inside, and would like to see the network, there is a command to be able to see all the details about a network, and it's called Docker inspect. By the way, if you worry about all of these commands, all commands would be in a link in the description section, and you would be able to see all these commands. So don't worry about forgetting any of them. So if I read this one, it would show me a lot of details, and you would see networks, and then you see like it's attached to the bridge, because this is a default one. Okay, away from all of this, we would like to access the container finally. So we write docker-p, and we say, please map maybe port 3000 into port 80, because port 80 is the default for Nginx. I know this because of the documentation, and also because I ran it before multiple times. And please don't forget the -d. So, and also we forgot to write the run. So docker run -p 3000 from outside into 80 inside Nginx. And when we do it, we need to make sure that it run. And now we see like new stuff. We see like it maps 3000 from the 000, which is a local machine, into port 80. So if I go to my browser now, and if I write localhost 3000, I now should be able to see Nginx running. All of this without doing any configurations. I didn't need to install any stuff. Before I was trying to install Nginx and do all of these things manually, I spent like at least 1 hour trying to get Nginx running. I spend more hours trying to get the configuration, searching a lot of websites. We now do it like in less 1 minute. So this is great. And I will get into more details about networking. Like I promised in this video, I will get into more details. And but at the moment, what we would like to do is to continue and maybe show different stuff than this, because this is a default page for Nginx. And now we get to the last concept, which is volumes. And of course, like this is not the last concept, of course, like joking, like there are many concepts inside Docker, but at least one of the last important concepts inside Docker, which is volumes. And what we did with ports is that we are mapping networking from outside into the inside, like to remove a layer of isolation. Volumes is to also move another layer of isolation, which is mapping files now from outside into the inside. So what we usually have here, we would have our server machine at this part, and then we would have our Docker container running. We would have our Docker container running here, and this in our case is just the Nginx server, and this is just to provide us configuration and not to install and do all of this stuff again. It could be like Java, it could be Python, it could be Go, it could be whatever language you would like to use, or MySQL database, which would come into details. Okay, so Nginx, we would like to add files inside it. So to add files inside Nginx, we need to either like have an image that already has this files inside, which would come also later about it, or we could expose the directory like we said. So we could say, okay, we would like to expose a directory from inside Nginx into a directory from the outside. And in this case, the outside directory would be where we store like maybe our index.js, maybe where we store the images, maybe where we store the CSS files, and so on and so on. This is one example. Another example, which would be much better than the whole Nginx thing, is the MySQL database, which is actually where it is used the most. Not also the most, you could also use it with normal containers. So you would have your database here, and then you would have the actual database itself, like where the files are stored. If you did this inside here, and then the container is killed or removed, your database is gone. So you don't have them, like you don't have them again. So what we would like to have, we would like to have data persistence. So to keep the data always available, always existing, and so on and so on. So the idea is that we would map a directory, which is inside the database, and then directory inside the host to say, okay, please get these files inside my container to be able to access them. And this is also the beauty of why we have Docker containers as processes. They are still a normal process running on a machine. They are not like something running on operating systems that require access through ports and then do complex communication and so on and so on. But rather it's just getting it through normal directory, like as if, okay, please open this one, like get outside of short, and then get access from this directory from the outside. And then it would map it from the outside into the inside part. And now we could keep data persistent. So we could kill this database and then data would still exist. Or, which was much, much better, and this is what actually people would do, is to have another container to do the read, like database read, and then another one to do more reading, and another one, and another one. You would have like multiple ones to do like the reading of data, and only one to write. And in this case, now we will have more scalable way to do like that, like reading data and writing data. The writing data doesn't matter much, but reading data would be making it more scalable to be able to like see, refresh like upvotes maybe on Reddit, or maybe like your comments and so on, and likes and whatever you would like to see. So it makes like reading much faster, and write would be like, it's a different story. Yeah, so this is what is volume. It's just like exposing one from outside into the inside. So the way to do it is just simple. Let's first get into the Docker documentation and to be able to see like which volume we need to bind to, because the outside doesn't matter where it is because this is on our machine, but the inside one, it's always has to be specific. So each service would specify which file to map to. And the command to do this part, or the parameter, would be -v, and -v would bind certain volume from outside into a specific volume inside. So we just like take our command like this, docker run, and then we do it like here, and we would remove the second part. And we could specify the exact directory where it is, but I don't like to do that. I would rather use something which is the environment parameter, and I would do it like that. I would just like dollar and open two brackets and write wpd, which says like the current directory. And I would go to my current directory and create like source, and then I would say new file and say index. Let's say like we just like write a simple HTML, hello from Docker. Of course, like it's not from Docker, it's from the host. And if I run it now, like I forgot to add the ports, so we need to map it to a certain port. So we're already mapping to port 3000. Remember, this is on the host. What we would like to do is to map now to another port, because you cannot map two ports, like two ports to like same port to two different machines. Doesn't make sense. You have to always one port to another machine. So we have to add -p and then say port 1000 from the host into port 80, which is always the same. And then I would run it, and then docker ps, I would see now it's running on port 4000. I would just go again, and then I would remove 3000 and write 4000, and it would say forbidden for some reason. Everything is running. And yes, because I said pwd, like I said like the current directory, but I should have specified which directory, which is the source. So I need to run again another one, maybe on port 4040 for some reason, I don't know. Let's do it, and then source, and then we do this one. Oh yes, because we have the same name, like we said, which makes sense also. We cannot use the same name. So let's remove the name. We don't care about the name now. And now we run it, and let's go to port 4040. Now we see like hello from Docker. And if I change it to some stuff, because it's a process, I still see the updates running. And because we are doing the mapping inside. And this could help me instead of creating my React app and using Webpack and doing all the testing and so on, and then pushing and then like hoping it works correctly on Nginx. No, I could use the Docker Nginx container and to make sure that everything is running correctly. Okay, let's do one tip, which is something away from all of this. If you write docker ps, you will see like a lot of images running or a lot of containers running. And if you write with -a as well, you would see like some ones which already exist. So there is a nice command also would exist on the like GitHub repository link. And this one, you just, let's clear all of this just to be able to see it up. And if you write it here, you see like docker stop, and then we write like another process and docker ps -a-q to be able to get all the image, all the containers IDs running, and then to stop them. So if I remove this one, just to be able to see what is actually returning, this is like a process running into another process. So it just gets the IDs, and if we do it like this, it would stop all my containers that are running in a single one. So docker ps, it doesn't show anyone, and I could do it again for the remove. So I could just, instead of stop, I could remove them as well to free the names to be able to be used again. One more thing about the whole volume stuff is that there are two types of volumes inside Docker, or with Docker. We have something called bind mounts, and there's something called volumes. So what is the difference between each one of them? Bind mounts is the ones that we already use. So basically you are mapping one directory from the outside into another directory inside your Docker image, Docker container. But volumes are mounting a certain directory that Docker manages into another directory inside your system, basically. So just like this part is managed by Docker. And yeah, this is the whole thing. This is the difference between both of them. And if we go to the DockerHub website itself to be able to see like more details as well, there is nothing much about it. It just says, okay, these are the named volumes, like these are the bind mounts, these are the ones that we already used. And you have like, of course, like more control, you know where they are used, but named volumes, they are just like managed by Docker. They have more stuff for them, like they are populated, if they have like some data inside the container already, you could populate it inside this volume, and you don't care about where this volume is stored. Mostly it could be like maybe for databases, local development, but of course like preference would be for bind mounts over named volumes. And of course, if you know any details about this whole thing, please leave them in the comment. I am also trying to learn all this part. So yeah, like most of the parts that I have used already was bind mounts. Named volumes are not much interesting, but they are just like you add like a name for the volume. So you need to create the volume first. So you'd say Docker volume, and then you would say create, and then you would say the name of the volume. You could say maybe my app for some reason, and then you could say Docker, and you would add dash v, like sorry, so you would add dash v, and then instead of the directory you would say my app, and then you would map it to whatever you would like to be inside your host, basically like HTML maybe, and then you would say the hd and nginx. So it's just like adding this to map like something from outside to the inside. And I forgot to add the run as well. So you add this part, and I was just mapping from the outside into this inside, but this is inside Docker. It doesn't exist on my machine. It may be like good for databases, or just like I would like to try around, and you don't want to keep it like here. And you would rather maybe keep it managed by Docker desktop. So if I open it, maybe I could open it from up here. Like this is also inside Docker desktop, and you would be able to see like volumes, and this is the volumes that we created. You just like maybe you would like to create temporary stuff to be able to test. That's all. And these are the other two volumes that we created, like mapping and hashing stuff. Okay, so now we have discussed everything about volumes. One last command as well that is also useful for Docker is Docker exec. And this one allows you to start another process inside your Docker container. So maybe you have, let's write Docker PS, and we see like this running container. We could write Docker exec, and then you write -it. I will say what is -it, and then the name of the container, and then the name of any process you would like to run. So what are these stuff? So exec would execute another command, another process inside your container. Like we said, a container is just a process, but it's a single process. But you could also execute another process as well. Maybe you would like to do stuff inside it. One famous thing would be used is trying to get access inside the container. I would like to get inside the container. And so far, it's like outside. We haven't logged into inside it. All of this were on my host machine. So to be able to access it is to execute like maybe bash. So we are able to create a shell inside the container and be able to get inside it. And the IT is just to have like interactive mode, because if I don't have the interactive mode, if I did it like that, it was just like execute it and doesn't show me any stuff. But if I add the interactive and now execute bash, and now I am inside my like this container, I'm now inside it. And if I write ls, I now see like the different files inside this machine, and all of these are the libraries that we said that they are supporting the container. They are inside like another root that we don't know where it is. Docker handles it, but also add these directories inside this root to be able to support Nginx, for example, because it requires third-party libraries to be able to run. So this is just like the exec part, which is very important. You could also, instead of this, you could run ls. So you could execute like ls inside and get like these files, like get the files from inside. And execute is just like what is the command you would like to run. And now the last part before starting doing the project that we already promised. All of this is just trying to understand what is Docker, like just you can imagine how complex it is. And this part is we are going to start like a WordPress instance using the network that I promised that we are going to discuss. So let's just clear all this part, and we are going to start WordPress with only two commands. Okay, before we start also we need to make sure that we have nothing important running. So we could do the whole magic command that I have here to stop all the Dockers and remove everything, just because you don't know. Okay, now we cleaned all the stuff. We clear, and now we would like to create a WordPress instance. And with WordPress, you need two things. You need, I wouldn't go to the board because it's simple. You need two things. You need like WordPress, and also you need a database. And you need to create a network between both of them to be able to resolve the IP addresses. And I will explain every detail what I am writing here. So the first part is we would like to create this network thing. So we say Docker network, and then create, and then we say maybe the name of it is Docker WP network. So now we created the network. To be able to see it, we write Docker network ls, and now we see there is a new network created here, and it's using the bridge driver. I haven't discussed what is drivers. I wouldn't discuss it in this video. Okay, now we need to run WordPress. And I already have an idea how to run WordPress. So I'm just like going to get the command from here. And before running WordPress, we need to run a MySQL driver, MySQL server or container. So this is the command to run it. So what each part of this? So the first part is docker run. This would we already know. Then we have dash network. This is to say, okay, please, and instead of running this container inside the bridge, please run it inside the WP network instead. Then we give it the name, which is WP database. And then we say, please expose this port. It's actually not necessary. So I could remove it. I don't need it because this would be inside a certain network. It is not like, it's not to the host. It's just like it would be exposed inside the network itself. I don't need it. And then we say dash E is environment variable. So it's also a parameter for Docker to define a certain environment variable you would like to use. So you could run inside the container. Maybe for our case, we would like to give a certain name to MySQL database. And we would like to give a certain password for the root user for MySQL. So you could define like each one, and each time you would add dash E and then the equal part. How I know about all of these environment variables? Again, all of this would be in the documentation of MySQL. So if I go to MySQL and then check this one, and if you go down, you would see like all the environment variables that you could actually use. And we just like need to define what is the database and what is the password. And finally, detach mode, and then the name of the image that we would like to get. Yes, okay. Now we run it. When we press run, it wouldn't find MySQL, so it first would grab it, and then it would like create it and install it. So now it is done. Okay, now we need to run WordPress. So I would just get also the other command to run WordPress. So we take the command here, and I also going to explain. So also run again network, the same network name, and we're giving it the name of WordPress. We are exposing port 8000 to the host because we need that to be able to access it from our local host stuff. And to be able to like local host 8000 and then 80 inside WordPress. Also all of this from the documentation. And we say, okay, this is a WordPress host name. It is not important because we are in the same network. So all of this is just like exposing the port and then detach mode. So simple as that. We just take it as well, and then we run it. And then we go to localhost 8000, and we should see WordPress running. So now we see WordPress is running. We say continue. We say, okay, we need to define what is the database. The database name, like what we have defined, was WP. Also to make sure that we did it correctly. No, it was, yes, it was WP. This is the name of the database. Username is root. Password is 1234. And this is the host. What is the host? It is actually not localhost, and it is not like a certain IP, but it is the name that we have defined, which is WP DP. Let's get it. Let's add it. Click submit. Let's say everything is running. Then run installation. What is the blog name? Say app.blog, and we give the name, and we set like maybe this password, and then we say the email, and we say, yeah, all of this is not important, and install WordPress. And it's now connecting actually to the database itself. And yeah, I don't need to log in. And if I go back, I see my WordPress is running, and I could do all of stuff. This is from database and so on, and everything is populated. Okay, what all of this, or how all of this happens, just to resolve what we have done. Okay, so the first part is that we created the database here. And this is the explanation, more explanation for the networking part, because it's actually very important, and I wasted a lot of time to trying to configure different Docker files and Docker Composes file to be able to do all of this networking part. So it's very important. So we have like the first one, which is the database, and the other one, which is WP. And we now here, we created the network. And now when we said the name for this one, you say like, okay, I would like to resolve to this name, because all of them under the same network, they have certain port inside them. They are already inside this network and they are exposed. And then when you say, if you said localhost, you would resolve to yourself, like it would resolve inside itself, not yourself, of course, like inside this WordPress container. So it would say, okay, I would resolve here, but there is no database here. There is no database, so it wouldn't find anything. It would say, okay, I cannot do anything, and let's kill me. So in this case, it wouldn't work. But when you say WPTP, you send it to the network, and the network does the DNS, like the resolution, and it says, okay, oh yeah, the container with that name has this IP address. I would redirect all your requests, which goes to WP, DP, and with this port address, because of course like WordPress sends to this MySQL port, and that's yeah, it sends to this port, and then I would redirect it from here. I would replace the name with the actual IP address of the container, and then redirect them to this container. And this is what it does. And we needed to expose the port, or publish, not expose. We needed to publish the port to the host to be able to access it from the browser. And we didn't need to publish this one because we don't need to access it from the outside world, for now at least. So this is all the two commands that we did, and we ran WordPress in 2 commands. And instead of like, I don't know, I used to spend like I said, like also hours to set up like Nginx, MySQL, download all of this, and then run it and install it. You could check one of the famous articles, like DigitalOcean install WordPress and then Ubuntu. And you would see like it's a huge list, like all of these commands you have to do. And this is maybe like for Apache, and there is also other one for Nginx. So yeah, instead of all of this and reading all this article, we did it in, I don't know, like 1 minute or 2 minutes, and that's it. And now we have WordPress running. So this is cool stuff. After we have covered the basics about Docker, now is the time to start building our 5 projects that I have promised. And during building the 5 projects, we also will discover like more commands about Docker and more like important stuff. And most importantly, we'll discuss Dockerfile and Docker Compose. And we'll discuss what they are, why they are used, and how to use them. So the first part we are going to discuss is Dockerfile. And the idea of Dockerfiles is that they are used to build the images. So normally when you are doing or building your stuff, yes, we are write files and we create volumes, but usually it wouldn't stay here, like your file wouldn't stay here, but rather you would like eventually take the image and have a single image and then run future stuff from it, like similar to what we did with Nginx. We didn't need to configure it, or WordPress as well. It's already pre-configured, and we just take it and run it, like take the CD and then run it in the driver. So what we would like to do is to build this image instead of us like doing it manually, like what you would usually do, which is like getting the container, running the container, getting inside it, doing some stuff, committing, creating an image, and then running this image. Okay, what I have said so far. So what you would do usually, like this is a normal part, like what people would do is to like, not normally what people do, what would happen without Docker files. So you would do like Docker run -it, because we would like to get the, not the -it at first. We take like -d, and then we say Nginx, and yes, everything is okay. Now it's running Docker ps, just to take the name, and we take the name, say Docker exec, and we get inside it. So Docker exec, and then the name of the container, and we say bash. So we now get inside it, we say ls, we get into user, I think it was So yes, it's this one. We just like take this one and we say cd, and this is the directory that we would like to go to, and this is where our index. So what we do is to maybe nano it. I think nano wouldn't be installed, so we have to get apt get nano, and if you do it, it would say operation cannot be done because various stuff, because you need to do like apt get update first to update the registry to get like the different links, and then you would say apt get install nano, because I would like to use nano inside this container for some reason. I don't like them. Yeah, we will have like a tutorial about them later. Okay, so now we get it and we say nano and then index HTML, and then we do bunch of stuff like maybe inside this one, hello from updated image, and then we exit, we saved it, and then we exit from our container. Just let's clear this one, and then we say docker commit, and I forgot the name of the image, so just ps, and let's get the name of the image, and then docker commit, and we write the name of the container and then the name of the new image that we would like to create. So maybe we could say updated Nginx. So now we created a commit and we created the image. How to see this new image? We write docker image ls. You find like ls is repeated like in network, and then the like containers also images, it repeats like everywhere. So write like this one. We now see our new image created. What was the name? Updated Nginx. So we have updated Nginx, and we could use it to run a new container. So we would run docker run -d, and let's now expose a certain port. We'll say 8000, and we expose to port 80, and we now say the new image. So we created the image, we change it inside, we committed it, the steps again. We get the image, we run a container, we change the stuff inside it, we commit it, and then we run it. Now, like create an image, and then we run it. And then we take port 8000, and let's go to here, let's refresh. And we see like the statements that we have written. Now we create like a new image and we cut them. All of this stuff is long to do. Instead of all of this, we could have a Docker file, and with Docker file, we could define the steps that we would like to do. Maybe copy files, maybe like get a certain image to be my base image, and so on. So what is Docker file? Docker file is getting all of the steps and doing them in like steps. It's like a bash. Simple as that. So what we would like to do is to create what we have done like using Dockerfile. So let's create a new folder, and we say maybe Nginx new or updated Nginx. Like this is the first project that we'd like to do. Okay, so let's take this one, and we have our source file, and now we create the Docker file. So we add Docker file, and this is what is going to define the steps for building this project. So the first part is to define what is the base image that we are going to use to build our project. So it's defined using the from statement, and then you would say what is the name of the image. So we have Nginx. Of course, like the thing that is autofilling this part is plugins that I have installed inside VS Code, and the name of it is I think it's Docker maybe. Yeah. Okay. So we say what is the name of the image, and then we say copy. We would like to copy what we have created, like this one, and we say what is the source and what is the destination, and we say the source is this directory. We say like source, and copy it to inside. We would say what is inside, but we say like now we just like throw it inside this part. Okay. And yeah, this is part we just like need to copy. This is what is the steps that we have done, and we need to define before this, we have to define something called working directory, because if we haven't defined it, we could write here the same directories that we got from Nginx that I forget. We could copy this part, we could add it here. Like you could copy like from source, from the outside world into this directory. But instead of doing like this, we just like define work directory, which is the current directory. for where to set, like it's doing basically like CD, it's doing CD, but it's just like, yeah, I would do it like in this step. Yeah, that's all. And what we do now is Docker build. And of course, we give it a name. We say this one up Nginx maybe, or Nginx v2. Yeah, let's name it Nginx v2. And we need to say where is the directory to run this Docker file. We just say dot, which means the current directory, and we just run it. So now it is going to build. I think the name was incorrect. I think it's rather tag. Yes, sorry about this. Instead of giving it a name, we give it a tag. Okay, so we run it like this. Again, yeah, I need to go to the directory. Yeah, all of this. Okay, let's run it again. So now it is building, and of course, like I did it quickly because it's just like copying stuff. And if I do docker image ls again to see the image, and now we see the new image, and just I could take it and do docker run -d and -p 8000, maybe 4000, because I don't know if this one is still running, and then the name. It runs, and then docker ps. Yes, we see like 4000. This is the one that run, and we give this port, and let's hope it works. So we remove this and we say 4000, and we see our file. This file now is inside the container that we have created using the Docker file. So this is the first project. Like I think it's a simple one. And the second one would be also like simple. So let's clear all of this, and let's remove all the container stuff. I use Control R, and I have like different commands to quickly check this part. Okay, just stop all, and we have to, yes, it takes a while. And now we have to remove the images that we have created. By the way, if sometimes stop doesn't work because stop is like something called graceful shutdown. You could use kill, which just completely kills the container. Like, okay, like I would destroy this container. Okay, so this is the first project that we have done. And now let's build the second project, which is Pinger. And Pinger or Ping is a tool inside Ubuntu, like, or any operating system that is used to ping like a certain certain URL to know the status or details about it. So for example, I could write ping and then www.google.com, and then I would get the IP address and get like some delay, TTL, and all of the stuff that I would know like how long or how fast the package or networking between this server. So what we'd like to do is to get this tool and add it inside a container, because might be in my operating system I don't have it. Maybe inside Ubuntu I don't have this ping. I would like to have this inside a container to be able to reuse it directly. So let's create our pinger, and let's create the Docker file, and we will know about two important stuff inside Docker file this time. Like each project would have like different stuff from the other. So we are learning Docker file by doing projects, and also Docker Compose coming up. So the image I would like to base from is Ubuntu this time. I don't want to base on Nginx because this is just like, I don't need Nginx, I just need the Ubuntu. So this now base. Now we would like to install the ping tools because they don't exist inside Ubuntu. This is a problem. So we'd like to deliver all of this inside our image as a package. So we would like to run like maybe apt-get, but you cannot do it like that. You don't do like apt-get install and then write it like this. You need to run it inside one of the Docker commands tools. So what is the command to run a certain command? It is called run. So we run apt-get, and of course we don't need the update. We don't need the install first. We need the update first to update the repositories, and then run the other command, which is to install the iputils ping, which has a ping inside it. And that's it. These are the two stuff that we need to install. But this is not correct to write, because for each Docker command, it creates a new layer. And why it needs to create these new layers? Because it helps Docker to cache. Why Docker caches? Because we would like in the future, when we try to rebuild the images again, we would like to rebuild them much faster. It doesn't take too much long to build them. So in this case, Docker would find, okay, this one didn't change, so I wouldn't redo it again. I wouldn't get Ubuntu, already have the image. I don't need to run the update because I already ran it up before. I don't need to run the install again because I already ran it before. So whenever the command doesn't change, it doesn't redo it again. But maybe with the copy, I would like to do it again because usually the files or directories would change. So in this case, with copy, it would see, okay, the directory changed with the metadata and hashing, and it tries to find if it changed or not, but it find it changed, and in this case, it would recopy again. So why we say that? Because, for example, you might, for some reason, you would do, okay, I would do the copy first because it's easier, and then I would do the runs, like maybe some run commands after the copy, and this is not correct because in this case, this would always change, and when it change, it would redo the other commands again, and we don't want that. So in this case, the reruns would be at the top. So this is regarding the layering, and why it is not correct, because actually you don't need to run tools, like make them into separate layers, like why create a new layer of image for this part. Maybe you just could run it in a single command. This is much faster, and it would cache the whole part in an image on its own. So that's why we write this part. So yeah, that's all, and now we could build our pinger tool. So we just like Docker, and then we write Docker build, and then tag, and we then name it pinger, and then we say dot, and now we build the current directory. And it says, oh yeah, I need to go to the directory for it. So cd pinger, and then build this one. So now it builds, and you see like it's now building and updating the repositories for Ubuntu. And after it would do it, it would now start like installing the package for pinger, and now it finishes everything. Now let's try to do it. So we would like to have something like ping, and then similar to google.com that we have written. So what we are going to do is docker run, and we need interactive mode to be able to see like the logs coming from instead of running in detached mode. And then what we would like to do is to run pinger, and we would write www.google.com. But of course it wouldn't work. Why it wouldn't work? Because it would see, like, if you try to read it, it would say, okay, I will try to execute the process which is called www.google.com, but it doesn't make sense to run this part. Okay, what was wrong? So this we haven't said before. For every container that runs, there is always a process that runs with it. And if you haven't defined it, it would always run the default process. And we can override this default process. So what is a default process? A default process for our image that we have built now is coming from Ubuntu, and it is bash. And what we have done by writing www.google.com, we have overwritten the bash default process with this process which doesn't exist, so it doesn't make sense. So that's why it doesn't work. So the other way, maybe also to give you a clearer example, if I just like clear this part and get the commands that I have written, and instead of www.google.com, I could write ls. And in this case, I am executing the process that is called ls instead of the bash, like that is coming from Ubuntu. So if I write like this, it would say, okay, I'm showing ls. Okay, how did I know about the bash thing about Ubuntu? Okay, of course, it's inside the documentation, but if you would like to see it, instead of writing any command, just remove anything, like everything, and it now runs the pinger, and it would run it in the default and with the IT, so interactive. So now if I run it, actually I would go inside my container, because this is executing bash similar to what we have written. Like, you remember we wrote like bash with the exec to create like another process. It is exactly the similar, but without running it, without adding any stuff here, it runs the default, which is bash. Okay, another example, if we just run Ubuntu. So I could docker run -it and then Ubuntu. And if I do it, now I am inside bash. Okay, what would happen if I remove the IT part? It would actually run and then stops. And if I do docker compose ps, the container is removed. And if I add -a, it would say, okay, it's actually like exited, like this one or this one. Yeah, this one is on. Why? Because it's just like started bash, it didn't do anything, so it gets out. But with the IT, it's actually going the interactive mode, so it is waiting or listening for our stuff. So this is the idea of having a default process for our container. So at the moment, it's just like getting the bash. But we would like to do is to override this bash and have pinger or the ping tool. How to be able, by the way, like how to be able to see the ping if we would like to do it like here. And instead of it's like ls, we could write docker run and -it and pinger and then ping and www.google.com. Now you start to see the pinging because we overwritten the bash with the ping. What we would like to do now is to override the whole bash thing that is coming from Ubuntu and now use ping instead. Or basically like say, okay, this Docker image actually is going to use ping. I'm not sure about the whole default stuff, but yeah, it's actually getting from it. So let's write entry point. This is the name of how to execute the command. It's called entry point. And then you have like this bracket is not necessary. You can remove it, but with having the array, you could also pass like you see here, like different parameters as well. So add entry point and then add the brackets and then we write ping. Now we have an executable that would always run when this container runs. So let's rebuild it, and it is fine by the way to rebuild with the same tag. So up, yes, this is the one. So build it. And now you see it runs faster because it cached, like we said, the other two layers, and it just like added this part. And now we could try it again, but without the ping, because now ping is the default. So we could add www.google.com, and now it runs. Okay. So now we could do that, but we could also do much more than this. We could actually add parameters. So we could say www.google.com, and we could rebuild it, and we don't need to add the whole www.google.com stuff. So we run it and we just like remove this w stuff. If we run it, it would run our stuff here, like you see. Okay, so this is executable. Entry point. There is another one called CMD. Now the question is, what is the difference between CMD or command and entry point? So let's just like add entry point down here, and let's just explain what is the difference. So the difference is that entry point would always run no matter what you write after the whole container stuff that you write here. But CMD is the default that would run, but you could overwrite it. Okay, so what do I mean? So if I remove this part and I could write ls just for an example, or maybe I could write like ping. Yeah, it makes sense. And then let's build it again. So let's go up and build it, and it builds fast. And then if I run docker run it pinger, it would run it. But if I write after this one, like if I write after the image name and I write like ls, it will no longer do the thing because it would overwrite the whole command. Like it would replace this one with the ls command, like you replace ping with ls. But if you use entry point and then use ping, it will never be overwritten. So in this case, if I do it like this, like I do ping, and then if I try to rebuild it again, and let's clear, and then let's try to run it. If I write ls now, it would fail because it would try to ping ls, which doesn't make sense. If I do it, it says ls is not an address. That is the main difference between CMD and entry point. It's just like more of a static behavior. You say, okay, entry point would always run no matter what you write after this part. But CMD, you say, okay, I would like to maybe like replace this one. So maybe what would be the use case? So the use case with entry point, it would be always like the commands that you always would like to run for this application. Like your application now is pinger, so you would like to run this one. But maybe CMD, you could write the parameters that would pass to the command you would like to run. So maybe you would like to pass www.google.com. So this would be one example to use like both of them. So let's clear this part. And then we say docker build finger again. And if we run it like this, it would run Google. But maybe I don't want to Google. Maybe I would like to dot my website, for example. And then it would replace. So always like it's, maybe you could think of CMD like it's the default. Of course, like it's not like that, but it's rather the commands that you would like maybe offering people to overwrite it. It has, of course, like very limited use cases, I guess, at least from what I think of how it's going to be used. But entry point would be much more. So entry point would be the application like Apache or maybe like Nginx, or like you have an application that you have built with PHP and you would like to run it. So you would say PHP and then you would add the other files that you would like to run. And we are going to see this part. But CMD would be just maybe like you would like to offer an example of how that tool could run, and then people could override it. By the way, you could still override the entry point. So we could add this part again, and instead of running it like this, we could add actually, let's just like remove this thing, and we could add dash dash. This is also an extra part. We could say entry point, and then we could overwrite it maybe with ls. And if we do it, I guess I read it wrong. Entry point, yes. So basically we now overwritten the entry point, but you see like it's a little bit of a hacky way. You have like, it seems hacky. You have to write like dash dash entry point instead of writing it over here. So yeah, this is the second example. Now let's try to do the third example. And the third example would be much more exciting, where we are going to build a Node application. So we will now serve a Node application. So let's go up and create a directory. And let's call this directory Node. Yeah, it's fine. Just an example. And of course, like all these examples we uploaded also on the GitHub, like the GitHub repository. So let's cd and let's go to Node. Let's close all of this. And of course, as usual, we don't care much about Node because it could be PHP, it could be Go, it could be whatever. So I'm just going to copy and paste. And I'm going to copy the project itself. I wouldn't copy the Docker file because I need to make you able to see it. So just like, oh. So let's go here and then pasting them. So now we have pasted them. And I'm going to explain what is this file doing. So basically it's just a package.json and we have an Express application inside it. We have node-mon that is used for development, and we have course to allow course access for this Node application. And it's simple. We just start an Express app. We allow course. We are using the layer for allowing to parse the JSON. We are using a semi-database, not an actual database, but rather it's a database by creating just a JSON file. And if at first we start that we are trying to find the database to exist, if it doesn't exist, we create this file. And that's it. Like we create the directory, and then if we don't find the file, we create it. And there are two endpoints. The first endpoint is get to get the to-do. So basically just like reading the file. And the other one is post the to-do, is to get the to-do from the API endpoint and just add it inside the file. Of course, like this part could be replaced with database. We wouldn't go with this direction, just to simplify as much as possible. And then we start the Express app and we listen on port 3000. And we have just like a process to exit the process, because if you click Control C, it wouldn't exit it. This is like just a minor detail. But yeah, this is the whole Express application, and we would like to deliver this as a Docker file. So what you would usually do, of course, like you take these files and then you npm install, and then you install your application. You start like node-mon, and then you would say, I would like to go to source and then index. Yes, I need to add npx, and it didn't install. tool. I think it's not nodemon, it's nodemon like this. Yes, now it started, and now we get our postman. Let's zoom in. Okay, so now it's working, and let's just close all of these old stuff. And now let's go to localhost port 3000. This is where our host is, and if we try to do get, we get nothing. And if we try to do a post, I would duplicate this part just to make it possible. And then we create a body, we create row, and we create it as a JSON. And then we send an object, and the object has item, and the item would be what to do. And then we send it as a post, and then it would add it. Oh yeah, it's not item, it's rather name. And then we send it, it adds it, and start adding it to the array. It's just simple as that. And the database would be created here from the app part, and it will create the JSON files that we have here. Okay, now is the time to deliver our application as a Docker file. And the first part that we would like to do is, as usual, is to create a Docker file. Okay, so this is the easiest part. Now we would like to base on the image of Node. Of course, like we need to base on a certain image, and this time we would base on Node, and we use Node 16. And we would like to go to a working directory to store our application, because we would like to copy our files from here and copy them there. And we add app. Okay, now we would like to copy. So what we should copy? Should we copy everything? Like, should we copy source, of course, and packages and package lock and node modules? Of course not, because usually this application would be stored on a CI/CD pipeline, and it wouldn't have node modules. And you are using the CI/CD pipeline to build your application and get the dependencies to install them. So we don't want to copy the node modules because we usually don't have them. Like, this is support. Of course, like if you have them for caching and other stuff, it could be added. But for our case, we would like not to include node modules. Like every time we would like to install them, maybe to use resolver for some reason. So we wouldn't use the, like, we don't want to copy node modules. So one way to do it is to add, like, maybe add the source, and we would like to create this one, and then add the destination, which would be app, and then create another copy and another copy. Maybe we could combine them all this directory, but the problem is that in the future, maybe you would like to add another directory and another directory and another directory, and you don't want to add all of this stuff. So in this case, we have something called Docker ignore, similar to get ignore. So we say Docker ignore, and inside it, we could define files that we don't care to be added. So we say, okay, I don't want node modules, and also I don't want the Docker file. Why do I deliver the Docker file inside the image that I would like to build? And now I could safely say, okay, copy everything into everything. And this is the thing that we would like to get. We would like to copy everything from here and copy them there. So that's the thing that we would like to do. Now, the usual, we would like to run npm install to install our dependencies. And of course, we could, one other way is to copy the package.json. Like, this is a more cleaner way, is to copy the package.json at first, package.json, and also package.json log as well. And let's add the other one. You could also add, yeah, I need to make it faster a little. So this one, and then you could do log, and then you could copy the JSON, then run the install, and then start the server. Why to do that? Because in this case, we are able to cache this first and cache the npm install. And if they don't change, it doesn't, like, it wouldn't cause like rebuild. Like, for example, if I change, okay, so maybe say it slowly. So the first parts, package.json and package.json log, they are representing our dependencies, and they don't normally change, but the source file normally changes. So that's why it is better to copy the dependencies first, then run the install. And if the dependencies didn't change. This means the installs wouldn't change, so it wouldn't cause any problems. And in this case, we could like save sometimes building our layers. But for simplicity for our project, we wouldn't do that. We just like copy and copy. I just wanted to explain this part, like the whole layering part. We just copy the package.json first, run the install to be cache this layer. If this didn't change, this means the second install wouldn't change. So in this case, we could just like copy the files and that's it. Okay, aware from all of this. So now we run the npm install and we would like to run the CMD. This is the command. Maybe we could use the ENTRYPOINT as well. It doesn't matter. And then we write node. And then this is the difference now. The previous one, we added only a single one. The update, I think it was inside the pinger. Yeah, we added it like that. We could also add like multiple parameters as well inside this array. Okay, so we now say source and index.js. And one last thing that we need to know is something called expose, and you could expose a certain port. So why is this needed? It's just needed for documentation. Doesn't mean that it would expose this port to the host, but rather it is needed for documentation to say, okay, this port would be exposed to the outside world. So we now just like say it to expose, but we still need to expose it. Okay, let's close our local server. Let's clear, and let's now docker build, and let's tag, and let's say node server. This is the name of the server, and this is the current directory. So now it would start building, and it would start running the installs, and it is done because it was a simple part. Okay, and that's all. Okay, now we would like to start. So docker run dash it, and not it even, we don't need the it. We add just like this, and detach mode, this is the important part, and run node server, and we would like to expose the port, right? So we say, by the way, inside it was 3000, so we need to expose from the outside 4000 and the inside 3000. And if we run it, docker ps, the image is running. And now if I jump here, and if I try to get on port 1000, I shouldn't see anything. So also one problem that it's copied the current database as well, which is a problem. And yes, so let's rebuild it again. And let's stop first. Docker stop this image. And it would take a while to stop. Yeah, this is also one thing. If it doesn't stop, you could just fire the kill. Like, hey, we don't care much about it. Yeah, it is already stopped. Okay. And let's rebuild it again. Let's clear all this part. And let's rebuild it. But this time we would add inside the Docker ignore, we would add also, we don't want source.dp. Because this is a database, we don't care much about it. We don't need it. So let's build again. Docker build node server. Now start copy, and let's try to run it. Port 4000. And let's go here and try to call. Yes, now we only have one. This time we ignored the whole database part. And if we did get of course, like 3000 is not the correct one. We need to use the 4000. So we do it, we only get the one, and we didn't copy the database. And now we created the image. After we created now the third application, now is the time to try something new about Docker, which is sharing. What we would like to do is to push the image into DockerHub and then be able to pull it inside DigitalOcean to be able to use it from there. So the idea is to be able to share it to some Docker registry and then use it somewhere else. And it's actually super simple to do. It's not super complicated. One thing that you need to do is to make sure that you have Docker login, like you need to enter this command and then enter your username and password to be able to authenticate with DockerHub. And of course, you need to have DockerHub account. Okay, I already logged in and have my authentication part, so I just need to push the image, and it's super simple. So how it's be done? First, we need to tag our image correctly. What is need to be meant by correct? What is meant by being tagged correctly is that it has the name or the company or organization, then slash the name of the image, and then colon the version for this image. And this is the format that is need to be pushed for Docker registry. So first part is to Docker tag it. So we say Docker tag. So we say Docker tag, and we would like to first get the name of the image. So image ls, and then we have the name is not server. So let's remove all of this, and then we say Docker tag, and then the name of the image that we would like to tag, and then the name of the tag that we would like to create. And I would create it under my username, so it's Abdovic, and then slash node server, this is the name of the image, and then colon, and then 1.0.0. This is how it would be tagged. And then let's make sure that it already exists. So we see it here, it is already tagged and has the tag for it. And of course it has the same image ID, like the same layer, because just adding a tag. Let's clear. And of course you see like the image size is quite huge. Okay, let's now push it. Of course not git push. It is Docker push this time. And we need to add the name. I forgot to copy it. Let's copy it. And let's clear Docker push. And then I add the name and then the version that I would like to push. And of course it will start pushing. It would take a while to push because it's huge. Okay, now it has pushed because we have, luckily we have a fast internet. And now let's go to my DockerHub account, and I should be able to see under my images, I would be able to see them. If I go here, my profile, and then I see the node server. It is now uploaded to DockerHub. Like I said, it's super easy. Now we go to DigitalOcean. Why DigitalOcean? Because it's super simple to do. Of course, like there is AWS, there is GCP and whatever you would like to use, but I would just use DigitalOcean because it's very fast. And I would create a droplet, which is a server. Go to Marketplace, and then find Docker. I click it, and then we get the image that we would like to create from. And of course, like, let's get the passwords. I have a password here that I would like to use to access this container, and then create the droplet. It's as easy as that. And the target is to get this image that we created on our laptop, and then we need to push it like into Docker, like we pushed it into DockerHub, and then use it here inside the Docker that we have created so far, like the Docker VM machine. So now it is created. Now what we'd like to do is to log into. So let's click the console, and now we have logged into the VM machine, and we would like to expose port 80 first because there is like some firewall, and we would like to expose port 80 to be able to access to this VM machine from the outside world. So, and it already has Docker, like where we selected Docker. So we say sudo ufw and then 80, and I think I wrote it incorrectly. Yes, it should be sudo ufw allow 80. This should be the correct one. So now we allowed port 80, and we already have Docker, so we just git pull this image. Not git pull, Docker pull, or Docker run. So we say Docker run, and detach mode, and port 80 from the outside, port 3000 inside, and then the name of the image that we would like to do. So it would pull it, and then it would install it. And it needs a certain version because we didn't push the tag for the latest. Yes, 0.0, and then it would run it. And by the way, it would fail. And the problem with this one is that this is the platform that it requires, like Linux AMD 64, but when we build it for this one, and we would like to change it to become this one. So what we are going to do is just add the platform, define it while we are building it. So just come back, and now we need to rebuild it again. And yes, this was the command, and we add dash dash platform and then equal Linux / AMD 64. This is the target that it requires. So it now it's going to rebuild it again. Now it's built, and now we need to tag it, but now we need to tag it with a new version. So instead of 1, we need to add like maybe the patch version and then push it. So we now push it, we push the new version. It will take a while to push. So now it's done. Now let's try to check if it's uploaded. If I refresh, I should see the new tag, edit. So now we have the new tag, and now we just need to pull it or run it again, or run the new version. So now we'll try again, and this time hopefully it would work. So now it run, and that's Docker PS, and we see our server running, and we just take the IP for this machine and we replace it here. So if I replace it with this one and I try to send a request, it would show me like an empty array. And if I try to post to it, I should be able to post. So post, it's multiple items, and of course get still works. Now for the fourth project, and this project is creating a React image. And again, we would learn new stuff. It's not like everyone is different, but also we learn more stuff from creating this. And again, I'm just like going to copy my React application and going to explain it as well. I created a simple React application using create React app. So I'm just like going to copy it, and after it is finished, now is the time to remove. Of course, like we need to remove the Docker files just to be able to show you how the progress happens. But this is just a normal React app, and inside there is a source and there is an app.js file. And what I created is just a way to read the to-do list that we have created inside the Node application. So it's just like a normal React app. It's a single component, and it has two states. First one to get the array or create the array, and the second state to have field to store the new items that is created. And then there is an one to send the API request to the to-do list application, and the other one is to fetch on start. So this is like a simple application, just fetch the items on start and then send request when we click enter. And also we need to see how it looks like. So I'm going to get outside and then go to React and then npm start. And then it would start my hello world application or hello React. Then let's go and see it. And of course, it would show me the first item because you remember we exposed the Node application. It's already running on port 4000, like it's the same port. So this is the port that I'm pinging in. And if I run Docker PS, I would see the first one, which is running on 4000, is sending to 3000 inside my application. And I could click add items, and it would add, and it would still communicate with the backend. So now we have like front end and back end communicating with each other as a to-do list. Simple to-do list application. Okay, what we would like to do now is to, instead of having the React application, is to add this inside an Nginx to now serve it. So now have a proper server to serve all this application from. So let's go and create. First part is the Docker file. And we also need the Docker ignore as well. Docker ignore, because we don't need some stuff, and we don't need the node modules. And let's close all of this just to keep everything clean. And let's go to the Docker file. And what we would like to do is to build the application and then serve it through Nginx. So what we can do first from Nginx. Of course, I'm doing the wrong way and I'm going to explain the correct way. And then I'm going to run, and then usually it would be apt get update and apt get install -y. I think Node.js would be installed like this. And then I would say run npm build. This is what usually you would do. And then this would be like the steps that you would do usually. But there is a problem with this part. The problem with this is you have Nginx. This is a server that you would like to use to serve your assets, but also you have Node.js. Node.js is only needed because you would like to build, and of course you would need to npm install your assets that weren't in the GitHub repo when you build this with CI/CD pipeline. So you have node modules, which is huge, and we don't need that. So in Docker, there is something called multi-stage builds. So you could actually build your application in one stage and then use files from it and use it in another Docker container to serve the actual asset or the actual container that you would like to use. So we first could create the build stage, build the stuff, npm install, npm build, and serve and all of this stuff. And then the second stage would be npm, just like copy the files and put it inside Nginx to serve our assets after the build. So the first part would be from, and we say node, and maybe this time we define 16, and we say run, and then apt get update, and then we need to define a working directory to say this is the place where we will do our stuff, and let's use user source. Of course, it doesn't have to be that, but yeah, you could have whatever you would like. And then we'll copy everything into everything, like copy everything inside our directory, and then run npm install and npm build instead of having like two different stages, npm run build. And also one last thing that we would like to do is to also remove the node modules to make sure that we are actually building, because I think we missed it in the node application. So we need to make sure that we already built. So this is going to get node modules, run apt update. Of course, like apt update is not needed actually, or let's keep it just temporarily if we need it. Or yeah, let's remove it. It doesn't make sense. Okay, and we have working directory, and we have the copy, and then we run the npm install, then install the packages, and then npm run build to build our application. So this is the building part. And then we could actually do from another one. So you could do from, and then this is another stage. And then we say copy, and you could copy from another stage. This is a part. And you could say from stage 0, but because this is numbered like from 0, and then if you have like other stages, like other froms, they will be numbered, but it's better to have like an alias for it or a name. So we say as, and we say build, like as if it's a build stage. And we say like copy from build stage, and you remember we have user and source, and it with React is going to add the files inside build, and we just need to copy them inside the Nginx directory or the correct directory for Nginx. So we add this directory, and that's it. So this would be the first stage. It is going to build working directory, copy, run npm install, and then run the build. And then for the Nginx, this is the final image that we would like to serve from. It's going to copy from build, and then it is going to copy from that stage, take these directories as assets, and then serve them in the HTML, and then serve the final image. And let's make sure I close this one. Okay, so I don't have any running processes. And also, let's keep the backend one because we would need it. Let's make sure I only have backend, and let's build. So let's Docker build, and this time we just like build it locally, and we say React frontend. and yes, I need to go to the front end. So cd react and then rerun it again, and it's going to build. Now let's run it, and we copy. Now let's run it, and then we copy the image, and let's clear, and docker run dash detach mode, and then port, and then we'd like on port 3000 for our machine, and it communicates internally into port 80 inside. Yeah, and we need to add React. And also to make this thing clear, because it's a little bit nice to see. So inside the node, there is port 3000, but on our machine, it is talking to 4000. So 4000 on our machine is calling the backend, but 3000 on our machine is calling the front end. And we have now a mixture of IPs. So now it should be port 3000. And let's refresh. So now it's calling Docker, but I know there would be doubts. So let's Docker stop, and let's remove this one, and let's fully remove it, and let's call it from port 8000 this time. So the front end would be on port 8000. So now if I go here and change it to port 8000, it should work as normal. And this is the fourth application. Now is the time for the fifth application. And with the fifth application, we will learn about Docker Compose. So we now learn about Docker CLI, we learned about Dockerfile, now we need to learn about Docker Compose. And Docker Compose, you can think of it, it's just a way to orchestrate multiple containers, or let's forget about the word orchestrate because it sounds fancy. It's just to run multiple containers at once instead of running like each container on its own. So if I would like at the moment, I needed to run the container for Node, or our Node.js application to connect it to React. So I need to run the Node container and run the React container, each one on their command line with /d, and I have to remember the correct ports. I have to connect them correctly. I have also to make sure that if I did changes, I have to build, I have to create a new image, and then I have to deploy them. So there are multiple stuff that we need to do. So instead of doing all of this, we just have a tool called Docker Compose that manages running all these containers with a single command. And instead of running each one on its own. So this is just the idea of Docker Compose. Forget about the word orchestration. I just run multiple containers at once. And it's similar to Dockerfile. Like it's similar to Dockerfile that we describe what we would like to do eventually. But the difference is that with Dockerfile, we generate we write the different layers that we would like to happen to build our image. With Docker Compose, we define what are the images and what are the different parameters that we would like to run this image to create a container from, and what are these parameters that this container would run with. So basically, it would be similar to what are the different parameters that we pass here. So it will be exactly the same. So we just define what are the input-output ports, what are the different volumes, what are the environments, and there might be, of course, different extra stuff, but we wouldn't focus much on this part because, like we said, this is just enough series. So let's start by writing the first project, and in this project we just need to run React and Node together at once with Docker Compose. So instead of writing Docker run React application and Docker run Node application, we would put both of them in a single file, and we could stop them with a single file as well. So let's call this one React+Node, and we define the Docker Compose.yaml. And Docker Compose uses the YAML format. It's similar to what JSON does, but just YAML has different formats than JSON, of course. JSON uses JSON objects. YAML also has key value pairs, and it also has an array inside it. Of course, there are multiple videos about what is YAML file if you don't know how to use it, but I will try to make it as simple as possible in this part of this video. So the first part we need to define is what is the version that we would like to run Docker Compose on, and at the moment I would like to use version 3.7. There is also version 2 as far as I remember, but we'll use version 3.7, and of course in the future we'll just like check the upcoming version and if there is any breaking changes. So we have, like we said, like we have a key and this is the value, and then we have another key which is services, and services is basically a dictionary. So you define what are the different services or different containers you would like to run. So at the moment we need to run two services. We need to run the service for the front end, and we need to run the service for the backend. So these are the two containers that we would like to run together. And inside the service, we need to define what is the build. And the build is like it's a path to the Docker file that we would like to build our images from. So we would like to go up a little and then go to React for the front end, and for the back end, we would like to go build, and then we would like to go up to the node part as well. And then we need to define the ports or the mapping for the ports, like input port to output port or output port to input port. And this is an array, so you could define different ports you would like to expose. So this one is a dictionary. It's like as if you are doing in JSON, you like front end and dot build, like similar to this, but ports, it's an array. It's like this. Of course, I think one day, hopefully, they will do like JSON. But anyway, so with ports, we need also to define the one on the host and internal, like 3000 outside and 80 inside, because this is an Nginx. And for the backend, we also need to define the ports, and we would like to define the output port would be 4000 and internally would be 3000. So we define build and we define port. Also, we would like to define the volume, because for Node, we also define the database that we would like to use. So you could also define volumes, and also you could define output to input as well. So we would like to say, okay, I would like to have the DP, like the .dp directory in my place to map to internal, which would be app/source/.dp. So it would create the DB file here, and I would just like add it here to say like this is the current directory. And yeah, that's all what we need. And of course, like yeah, this would be the last part. We will discuss about the networking the next part. Okay, we just now go to the React node part, and we just say Docker compose. Maybe also I would clear all of this to make it more clean. So Docker compose. And for compose, we have two important commands. We have Docker compose up to start all the services, and we have Docker compose down to kill all the services. And with Docker compose up, we could run it also in detached mode. So basically run it and leave it without seeing the logs, or we could keep it in non-detached mode, like without the detachment, to be able to see the logs. So we will just like run it in detached mode, and it start by building the images for posts of our applications. Like I said, like in a single command, instead of writing this one and building this one and deploying and all of the stuff, it would do it in a single command. But I think it would fail because the ports are already mapped. So while it is running, let's check that we don't have any commands running. So probably we need to kill both of these. So let's kill them. So Docker stop this one, and also let's stop this one. So it would stop them, and hopefully this would be before this one starts. Yeah, it fails because, of course, like supports are already used. Okay, let's make sure. Docker PS. Okay, let's restart it again. Docker compose down to kill, because we already created some stuff, and let's do it again. Docker compose up -d. So now it started it, and Docker PS, Now we see the two images running in a single command, and I could just go here and go to port 3000, and I see my application is running, and I could add stuff to my database, and I could do docker compose down to kill my services, and after it stops I could do like docker compose up again. Of course that could take a while. Yes, and then we could do docker compose up. Before I do, I need to make sure that is broken, and docker compose up started with both services, and now I still have the list because it maps with the volume. And yeah, this is the fifth project now, and using docker compose. And docker compose is really simple. It's just configuring what you would like to run eventually. So you understand what is the Docker CLI, what are the different commands, and also how to build Dockerfile. Now we could also build multiple containers inside Docker Compose, and this would help, for example, when you have multiple containers you would like to run, because you have like a host and client, and then you have your front end, and you have like another service for the database. You have like 5-6 services, and you would like to run all of them in a single command. Now the last project, and this would be the fun part, which would be using WordPress. And we would run WordPress with a single command. So let's create new. And why it is like that? Okay, yeah. WordPress. And then we create another Docker Compose. And we say YAML. And we can add the image now. This is different. The previous one we added the build. This one we will add the images for WordPress. So I will just also Docker compose down this React node just to make sure that we don't have any running containers. And we need to go to the other one. So I'm going to cd and then go to WordPress, and let's clear it, and let's do it again. So we define the version 3.7, and then we define the different services we would like to run, different containers. And with this one we would say WordPress. This is the first service, and the second service is a database that we would like to run. And with WordPress we wouldn't use build, we would use a already created image, and we could write WordPress only, but I would rather use the full name, so I would use it with the version. So we would like to use WordPress version 6 with PHP 8, and with the image for the MySQL. For the database we would use the image for MySQL. And let's move this one here a little bit beside, and then we need to expose the different ports that we would like to use to access our images. So for WordPress we would like to access port 3000 from outside to be able to access it, and port 80 from the inside. And for the database we don't need to do any stuff for it, because we don't need to access it from the outside world. And for the database now we would like to also store it, like to keep it persistent basically among different reruns. So I would use the volume on my machine, which would be dist host, and then I would like dist host.dp, sorry, and then I would like to map it to var lib MySQL, and this is basically inside the MySQL. So this is one on my machine, this one would be inside. So now we created the database, and we would like to network both of them. Remember the network parameters that we added before, to be able to make them connect to each other and resolve each other. So we would create a network, and we call it WordPress network. And this one needs to be also like this, like it's a key. We don't need to add the extra parameter here, we just define the network, and we define each one of them would use the network for our created network. So we say network, and we do it the same also for the database. So now both of them should be connected, but we also would add more stuff. So we could add also the different environment variables for WordPress to be able to run it directly instead of going to the installation and doing all of this stuff. So all of this, of course, like on the WordPress Docker image or Docker description on the Docker Hub installation. So we define the database username and password and database debug. Okay, before describing this part, maybe I would copy better also the ones for the database, because it makes much more sense, because we start actually from the database and then map it to MySQL, map it to WordPress. So you have the environment, we define the MySQL database, we say this is the database name, this is the user, this is the password. Of course, you could write it 1, 2, 3. And there is a random root password. We just like define this one as well. But these are the two important parts. And yeah, we could remove this part. Maybe it is not needed. Yes. Okay. And then we say the database host name that we would resolve to, which would be our service. Remember, like we map the service name or the name of the container, and then the network would resolve it to the IP of the container. And then the username would be the same username, password would be the same password, and this is just the database name to create it, nothing else. It would be this one. Okay, and we just enable the debug mode, just like something to be able to see parts. And lastly, there is something, because I have my M1 machine, so I need to define something called platform, and then we need to define the Linux AMD 64. You remember this one? Okay, and I just finished. And let's do docker compose up -d, and we will start pulling WordPress and pulling the database, and it will start running or building or pulling, not building. Okay, now it is done, and now it is starting post containers. One important thing that you would need to know, if you run in detached mode and you would like to be able to see the logs, you could run this command, and it also would be on the DockerHub list of commands. So you run docker compose logs -f -tail, and then number of line you would like to be able to see at first. So you could say -1 because you would like to see all the old logs, and then the name of the service that you would like to see. Or you could just like do it like this. Yes, I think we need to add the service name. It's --tail, sorry. Okay, now we hooked into the database, like inside the logs for the services, and now we see everything. So yeah, of course, like this is not the best solution, but let's see this one. So the problem with this part is that we need to define one of these environment variables for our MySQL to run, and yeah, I forgot to add them. Of course, like I now remember why we needed the random part, but let's add for the root one. So let's just copy the root and then add the root MySQL to be 1, 2, 3, 4. And instead of logging in using the let's make it as a string, and instead of using the tail to see the logs, let's now use docker compose up only without the detached mode to be able to see all the logs as well. So now we see the database is starting up and it is creating the database, and yeah, it would take a while to finish. So now seems the database is up. Let's try to refresh, and everything seems to be fine. So let's click continue, and we could add log name, and we could of course add the username. But there is one thing important about WordPress, is that we also need to expose the volume for the plugins and theme, because it eventually helps to keep them consistent when you close or docker compose down the WordPress, and then when you would like to up them again, if you didn't map the plugins and themes inside WordPress to the outside world, and then you close the container, start again, all the plugins and like themes would disappear. So we just like need to put this down again, and then we need to also create a volume for our WordPress, and let's check it on DockerHub. So let's go to DockerHub WordPress. This is how usually what I would do, and I would find the name in the description, because all of this is actually super easy to do, but might be hard to understand a little how to do it. So let's copy this part and let's add the extra volumes here. So under ports, and we add volumes, and this is from the inside, and then I would like from the outside to be maybe under WordPress, but I need to do it like this, because if I didn't do it like as a pass, in this case this would be the named volumes, and I would like to keep it here to be able to reuse it. So we could actually put it under this here. Yeah, everything should be fine. And then we say docker compose down to be able to remove everything, and let's delete this one as well to restart up, and then docker compose up again, and it will do the same parts again. And you would see here like this part is saying like copying now, so it is copying what's outside into inside. This is something inside WordPress, similar to what we did with the Node applications, that we didn't find the database JSON file, so we copy it from inside to the outside to create like a random JSON file. So this is something you have to do. It's something doesn't exist natively inside Docker itself. So at the moment we will be able to see inside the list, we see also the WordPress files are being copied at the moment, and we see also the database being created here. So we now could keep them. When we close and then start again, it would be able to stay persistent. And again, all these files and stuff would be available on GitHub. So let's go back and try to do a refresh. Hopefully it works. The server, I think, haven't started yet, because it's still copying the WordPress parts. So it is still working. Let's try to refresh. We could also check the statuses for the containers. So docker ps, and it's already started. Okay. Yes, and WordPress now is finished. Okay, seems fine. So let's refresh. Yeah, it takes some time to copy the files, and we could click next, and we could say abdo plug and abdovec and any random email for now, and let's copy. Let's make this password easy just to be able to configure it. Yeah, and now it's still installing the database, and we can log in. And you can say admin 123 or 1234 and my username. And now, like you see, we have now WordPress in a single file. We didn't need to do much to be able to install WordPress, and I could add my plugins and click add here. Everything is configured, and I'm able to start right away. And I could have my files here, and I could also like do the whole development part for WordPress. But after all of this, this is not only related to WordPress, but rather could be applied to any systems that you would like to try out, like maybe Ghost, or you would like to try Drupal, or you would like to try Storyblock, or whatever system you would like to try, or Strapi. This also I would like to test at one point. So yeah, like you see, everything is just very smooth with Docker, and development is super easy. So this would be the end of this video. I know it was a long one, but hopefully you learned a lot from it. Of course, if you like it, please leave thumbs up in this video, because it helps with the algorithm. And yeah, see you in the next tutorials. Ciao.